So all through math, you have been developing skills for solving for x, right? Very basic ones, x plus 5 equals 7. You're like, what you do to one side, you do to the other side. Then you learned how to get rid of a squared with the square root. Then you learned how to factor. Sine, cosine, tan. You learned about sine inverse, cosine inverse, tan inverse. And now we're going to look at solving equations where the x is either inside a logarithm or inside as an exponent. So this right here is solving a logarithmic equation. That means you have an x inside of a log. And these are where our log laws that we've been practicing, this is where they're useful. So if you're solving a logarithm equation, first of all, we're going to want to get a single logarithm. Can you see in this log equation, you have two logarithms. So how do we get a single logarithm? Well, that's simplifying. We have our log laws. If we can put our logs on the same side of an equation, which they are already, I can put these two logs together because the bases are the same. And there's a log law that says if the bases are the same, we can multiply. And if I multiply, I would get log 3, base 3 of 9x squared equals 4. So once you have that single log, and this one, put a red circle around it. I don't know, I'm trying to figure out how to make step 2 really, really important. Because every year, this is the step that seems to be the hardest. And probably because it's the least mathematical step you've ever done in your life. It's weird. Because you have to use the definition to change to exponential form. The box around it. I don't know. I've tried so many things. This is the step that's hard. How do you get the x out of being inside of a logarithm? The way to do that is to change to exponential form. What does that mean? And I'll do this whole step in purple. The base is 3. The exponent is 4, and it's going to equal 9x squared. And what makes this step from here to here, star, 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 so hard is it because it looks so different from the step above. Like, we completely changed what it looked like. And because we're completely changing the way that it looks like, our brain does not like that, and we forget that step. Okay? But anytime you have a single logarithm, you can write it in exponential form. And because the x is inside what's called the argument of the logarithm, because it's inside, once we change it, well now this is 81 equals 9x squared. You know how to solve this. This is an equation you've solved tons of times. We can get the x squared by itself. Square root both sides, don't forget the plus or minus. So step 3, you can now solve for x. And lastly, because you can't take the log of a negative number and you can't take the log of 0, we have to check for extraneous roots. you cannot, just like you can't square root negative numbers for logarithms, you can't take the logarithm of a negative number, and you can't take the logarithm of 0. So when we go to our answers, which are plus 4 minus 3, we have to go back to our original equation, and we have to verify. If I plug in positive 3, so these are my two possibilities, positive 3 and negative 3. If I plug in positive 3, I'm just worried about whether or not inside the logarithm there will be a negative or a 0. Well, 3 times 9 is 27. That's a positive number. That's fine there. And if I plug in 3 into the second one, 3 is a positive number. That's fine. So I can say this one is okay. But if I go to negative 3 in the very first one, 9 times negative 3 is negative 27. That is going to be a wrong answer. Okay? If on the exam, you just went from here, x squared equals 9, to x equals 3, you would lose a half a mark for not showing that you know when you square root you have to remember the plus or minus, and you would lose another half mark for not canceling out the answer that doesn't work. So they're very picky, even though you go, oh, I knew that the negative 3 wouldn't work, so I didn't put it. You have to show that work. You have to show that you understand that when you square root, you get two answers, positive or negative, and that you checked it to show that one of them doesn't work. I'm going to take these steps, copy them, so we have them for example 2.